Hello everyone, I'm Jeremy Gibango Cantin, and today I will assist you with Laplace transform of a unit step function using the definition. Okay, all right. So I have three small questions here. It's very interesting, so let's go into it. This is my first question. So number one, I have a unit step here. I need to transform this. It should be 0 when t is less than 2, and then it's give me 3 when t is greater or equal to 2. Please, this is unit step. There's a notion that I listened that I worked on this. Okay, so now how do I separate this? We know that our f of s should be equal to integral of from 0 to t tend to infinity of what? Of f of t multiplied by e to the power minus st dt. Okay, so this is our t. This is our f of t. So we have to write this in terms of that. Okay, so I'm gonna have my f of s should be equal to here, number one. Okay, it's gonna start from where? From 0 to what? To 2. Okay, and then we write f of t. What is the value of f of t there? The value of f of t is 0 multiplied by e to the power minus st dt. All right, plus we're talking about the second one. The second one, it gives us 3 and the 3, okay, times e to the power minus st times dt. But what is the interval here? When f of t equal to 3, it means t start is greater or equal to 2. It means we're gonna start by 2 and then t up to infinity. All right, so from there, let us solve. And this part is giving you 0, so we don't care about this, so we have to solve this part. All right, so this part is very simple. I'm gonna have integral from 2 to infinity of what? 3 e to the power minus st dt. So obviously you can take that 3 outside. You have 2 here, you have infinity there, and then you have e to the power minus st dt. It's very simple. It's gonna give me 3 times what? The integral of e to the power something, it give you 1 divided by that's something in front of the variable, and then you put e to the power everything, okay, as it was. Okay, but here I have my limit. My limit is, let me write it here. It gave me 3 times 1 over s e to the power minus st, and the limit was what? From 2 to infinity, t tend to infinity. All right, so definitely I've shown you many times that when I have minus s t and then I have to replace by the upper limit, which is infinity, it's gonna tend to 0. Okay, so the first part is gonna give me 0 minus, I open the big bracket and I'm introducing the lower limit. The lower limit is 2, so it's gonna give me 3 times 1 over s e to the power minus 2s. Right, that was it. Okay, and then here I have to simplify. It's gonna give me minus times 3 over minus s, which gonna give me only 3 times 1 over s e to the power minus 2s. Okay, that's our solution. All right, good. Now let's tackle the second question. The second question, they say I have g of t equal to 2t u t minus 1. All right, so how do I define this? Simple. It's gonna give me what? G of t equal to what? Give me 0 when t is less than 1. Remember, when you say u of something, that's the control. All right, everything depends on that. So I'm checking this part, it's gonna give me this, and it's gonna give me 2t when t is what, greater or equal to 1. Same thing apply, it's gonna give me what, when I'm gonna find out big J of s, because the function is J. Do not write for me f of s, because this is not this, it's not the same function. All right, J of s will be equal to integral from where, from 0 to what, to 1. It's gonna give me 0 e to the power minus st dt, plus the second interval, it's from where t is greater or equal to 1. So it's going to start by 1 to what, to infinity, t to 10, t tend to infinity. All right, so that function is what, 2t, and then e to the power minus st. All right, dt. Are we there? So here we have two functions which cannot be simplified. Then how can we solve it? We're gonna use a table model, integration by part. Okay, and if you don't know integration by part, you have to revisit my lessons on integration by part. Okay, all right, good. Now let me take this part. It's gonna be 1 to infinity 2t e to the power minus st dt. And this part, you know that it's going to give you 0 because I'm multiplying 0 by something, so it doesn't matter, it's going to give you 0. Okay, let's go. So here I'm going to do integration by part. Let me draw the table. Please, you must know this table by heart. This is differentiation, this is integral, and we put the first function is 2t, and then the second function, it goes to the integral. So what I'll be doing, I will differentiate here and I will integrate that side. This differentiation give me 2, and this integral will give me 1 over minus s e to the power minus st. All right, so we continue. This one give me 0, and this one gonna give me 1 over s squared e to the power minus st. All right, and then the sign here goes plus minus plus. All right, it's alternate. Okay, then I'll take this value and put here. And how do I put it? How do I record it? With my light. So I will record this in this format. It's gonna give me like this, pam 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 pam, and then I put the integral right there. Okay, so my answer will be equal to, it's gonna give me plus times 2t, it's gonna be 2t multiplied by 1 over minus s e to the power minus st. All right, the second one will be minus 2 times 1 over s squared e to the power minus st. And the last one is, because it's 0 here, I don't care about it. Then I can put my limit. My limit goes from 0, from 1. All right, it goes from 1 to what, to t tend to infinity. All right, so definitely when you put infinity right here, it's gonna give you 0. If you put the infinity here, it's gonna give you also 0. So the first part will be equal to 0, and then this is the second part. The second part, I'm putting the lower limit. The lower limit is 1, so I'm gonna put everywhere there's t, I'm gonna put 1. So it's gonna give me 2 times 1, which is 2, times 1 over minus s e to the power what? It's gonna give me t is 1, so it's gonna give minus s, minus what? 2 times 1 over s squared e to the power minus t equal to 1. It's gonna give me minus s. There we go. And then here I'm just gonna multiply minus by each term, so it's gonna give me 2 over s e to the power minus s, minus give me positive 2 over s squared e to the power minus s. There we go. This is your Laplace. We're using the first principle, and I will do this again using how do you call it, the table method using the formula sheet. Okay, I'll do it but on later stage. There we go. Now the big question. All right, so this is our last question, number 3. So they give me a piecewise function like this. How can I solve this question? Number 1, I have to transform it in form of unit step, and you must know how to do it. All right, so the first thing here, it's gonna give me f of t equal to what? Equal to 0. All right, u of what? T minus 2. The second one, this is the pulse function, right? It's gonna be plus what? 4 t minus 2. All right, open the big bracket, it's u of t minus 2 minus u of t minus 6, and I've closed my parentheses. Okay, and then the last one will be plus 16 u of what? T minus 6. All right, which means if they give you something like this, you must be able to write it this form. All right, so vice versa. Okay, now this thing become like this, and then we have to solve it. All right, we have to solve it. So basically you could have solved this immediately. So you have 0 times u blah blah blah, it's gonna give you 0, so we don't care about that part. We're gonna focus on these two parts. So we're gonna have f of t, we're simplifying it, it's gonna give you 4 t minus 2. all right, I open this, it's gonna be u t minus 2 minus u t minus 6, and then I have plus 16 u of what? T minus 6. Okay, so what's next step here? We have to simplify. We're continuing our simplification, which means we can distribute this. So this is the same as 4t minus 2 unit step of t minus 2, and I will have minus what? 4t minus 2 u of t minus 6 plus this thing 16 u of t minus 6. So I want you to remember something. The control here is where you see u. Every time you see u, that's your control. That is your control. You have your control. Your control is this. These are your control. Everywhere you see u, that's your control. Be careful, my 4 looks like u, so you must be pay attention. Okay, so but now what do you notice? This question, you can solve it in 2 ways. It's either you decide to continue simplifying further, or you can work with as they are. Okay, but I will for you to make it simpler, you can write this question as, you can write it as f of t equal to 4t minus 2 u of t minus 2 minus, you put a big bracket, 4t minus 2 like this, u of t minus 6 open plus 16 u of t minus 6, you close the bracket. Okay, so now you have to deal with everything part by part. This is my first part, This is my second part, and this is my third part. This is your A, B, C. So you can solve them separately, and at the end you combine them and you put them back there. So okay, let's do it separately. Remember, I thought there was another possibility, but if you expand this, you can group and simplify it. Okay, but I want to do it one by one. Okay, so I'm having, what am I having here? What am I having? So part A is the same as I have 4t minus 2 u of t minus 2. Okay, so I have to find this part. All right, so it means A of s will be equal to what? Number one, you have to transform this. It's gonna give you 0, give you t less than 2, and then it give you 4t minus 2 when what? T is greater or equal to 2. And then this is the same as integral from 0 to 2. Okay, it's give you 0 e to the power as t dt plus integral from 2 to infinity of 4t minus 2, like this, e to the power minus st dt. So we're gonna tackle only this part because this part it gives you 0 already. So I'm having only this 2 infinity 4t minus 2 e to the power minus st, and we know that we cannot simplify this any further, so we're gonna just use the table method. I have differentiation, I have integral here, so I have 4t minus 2. all right, and then here I have e to the power minus st. Okay, what is the differentiation of this? In differentiation is going to give me 4, and the differentiation in integral of this is going to give me 1 over s minus s e to the power minus st. all right, so it's very simple. The differentiation of this give me 0, this one give me 1 over s squared e to the power minus st. okay, and then I have plus minus plus, and then the same way I'm gonna record them as pam 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 with integral here. So I'm gonna have something like this. It's gonna give me 4t minus 2 divided by minus s e to the power minus st. okay, then I have it's plus minus plus, sorry, this is minus here, middle term is minus, plus minus plus. Okay, it's going to give me minus 4 over s squared e to the power minus st, and the last part doesn't matter because it's going to give me 0 there. So my limit is from 2 to infinity, t10 to infinity. Obviously when I put infinity there, it's gonna give me 0, and if I'm putting the lower limit, if I put 2 here, all right, I'm gonna get, what am I gonna get? It's gonna be 0. You can see that. So this part is 0. all right, this part is 0, so I'm gonna tackle this part. So I'm gonna have minus 4 over s squared e to the power minus 2s, which is definitely minus times minus gonna give you 4 over s squared e to the power minus 2s. So you know what I like about this question? Look at that. This question are the same, but I only change the limit, because look at b. Now my b will be equal to what? My b, look at my b. My b my b is how do you call it, my b is 4 t minus 2 u of t minus 6, all right, which is definitely it's going to give you 0 when t equal to less than 6 and give you 4 t minus 2 when t is greater or equal to 6. Okay, so basically this thing, the first part, you know that it should be from 0 to 6, give you 0 e to the power minus st dt, plus the second part will be from 6 to infinity, 10 to infinity of what, that function, which is 4 t minus 2 e to the power minus st. You see how beautiful and simple this thing is. So we're gonna tackle only this part, right? So this part is 6 infinity, I have 4 t minus 2 e to the power minus st dt. Now it's so simple because I already solved the same question. This is the same question, but the problem is we change the limits. All right, so this is gonna give me what? It's gonna give you 4 minus t, 4 bracket 2 t minus 2 over minus s e to the power minus st minus 4 s squared e to the power minus st. And then the limit change now. The limits from where? From 6 to infinity. You see, that's great and simple. So I'm gonna replace them. So let's see. When I replace 6 here, well, obviously it's gonna give you 0 for the first. When I put infinity here, all right, it's gonna give me 0 0. Wow. So now I'm putting the lower limit. When I put the lower limit here, what will happen? It's gonna give you 6 minus 2, which is 4, times 4, which is gonna give you 16. All right, and then here it's gonna give me minus 6s. All right, minus 4 x squared s squared e to the power minus 6s. And then this definitely will become positive 16s e to the power minus 6s minus 4 minus plus. Okay, there we go, 6s. All right, and the last part, and remember we're gonna put it where it was. Okay, and the last part, okay, write it here. The last portion was what? Let's see. My c was 16 u of t minus 6. Look at how cool this question is. So basically this is the same as 0 when t is less than 6, and this is 16 when t is greater or equal to 6. So basically it's gonna give me from obviously 0 to 6, 0 e to the power minus st dt, plus integral of what? From 6 to t10 to infinity of what? 16 e to the power minus st dt. So we're going to integrate only this part, which is very, very simple. So I'm going to integrate from 6 to infinity of what? 16 e to the power minus st. Definitely you could have just written this one outside, 16 here, all right, and then you have something like this. It's going to give you 16 times 1 over minus s e to the power minus st, and then I have to do the limit here. It's going to be from 6 to infinity. So what will happen when I put infinity here? I get 0. When I put 6 here, I'm going to have, okay, when I put 6 here, it's going to be 16 over minus s e to the power minus 6s, which is, it's give you what? Give you positive. So it's going to be 16 over s e to the power minus 6s. So now our final answer will be combined. So it will be combined. Let's see what was the first part. The first part gave us a gave us, so now I have to write big F of s. All right, A gave us, this is A, oh sorry, I have to because I'm writing on this paper. So A gave us 16 over s e to the power minus 6s plus 4 divided by s squared e to the power minus 6s. Okay, now that is your A. I have minus here, minus, and I'm gonna write my B. What is my B? My B was, what is my B? Sorry, I apologize. My A was, actually this is my A. It was 4 over s squared e to the power minus 2s. Okay, and then my B, this is my A, right? Minus, my B was what? 16s 6s plus 4s squared e to the power minus 6s. All right, and then my C plus C, my C was equal to what? 16 over s e to the power minus 6s. All right, so what is left here is just simplification. All right, so let me write it like this. I have 4 over s squared e to the power minus 2s. So I'm going to multiply the minus inside, so it's going to give me minus 16 over s e to the power minus 6s minus 4 s squared e to the power minus 6s, and then this one will be plus 16 over s e to the power minus 6s. So we can see the like terms here. Obviously this is, we're talking about my gs. Okay, this is my gs, right? It was f, right? It's going to be my fs. All right, so we're going to simplify it. We can see like terms. Okay, you can see this goes with that. Okay, so basically I'm gonna remain with 4 over s squared e to the power minus 2s, and then minus 4 s squared e to the power minus 6s. So this is your final answer, but if you want to go further, you can definitely put 4s squared there. So now I have e to the power minus 2s minus what? E to the power minus 6s. So it's up to you. There we go. So please, that was it. If you have any question, you can put on the comment section. Thank you for following this.